Next, we have with us Prashanth HN. He's an AWS serverless hero. He's also the Chief Technology Officer at AntStack. He has experience in scaling up an e-commerce startup from zero to raising 12 million US dollars. He's India's first serverless hero, one of the official contributors of AWS Amplify. Can we have Prashanth on stage with a loud round of applause?
Hello everyone. There's still people coming in. So unlike the other stage which Ashwin gave the talk, this is a lot of light hitting the face. At least I will have good photographs, unlike him. I'll just, yeah, please. People who take the best photograph of me will get a goodie. Crowdsourcing. So today I am going to talk about, as the slide says, serverless for startups. So a little bit about me. I don't know which side to move to. Probably. This works? Okay. So why should you listen to me on this topic, right? So I have been a founder from almost 15 years, I guess now. My first startup was Style Tag, which was a fashion e-commerce company. We started in 2010, 11, before Myntra, before Amazon and all that. So we were very early into the e-commerce space. Raised $10 million, ran it for 7 years. So that was my first startup. It was a large team and everything. And after that, I started something called as Wheelsbox, which was into more of a car buying experience space, like improving new car purchase experience. Unfortunately, that did not last long because the automobile industry fell in 2018-19 period. And after that, in 2019, I started AntStack along with Jeevan and Latif. Which is focusing on serverless, right? So when we started Wheelsbox, I built this Wheelsbox entirely on serverless. So we were like a very small team, like 5 people team, built the full product in the matter of 8 months. It had EMI calculators to, lot of complex things. It's not like an MVP kind of a thing. And we managed to do it 100% on serverless in the matter of 8 months. So that's about me, and let's get started. So I have a question to start with. What is the most important thing as a startup? Like you are building a new product, what is the most important thing for you? Time. Go to market. Yes, correct. I think you got it spot on. Customer feedback, right? It doesn't matter what you do, like Ashwin also said in the morning. Like you may have amazing engineering, crazy process and all that, but if you are not shipping what customers want, all of that is irrelevant. It's not relevant at all. So customer feedback is very, very important as a startup, right? So few examples here, like startups which started as completely something else, and through customer feedback, how people are using their product, they kind of iterated and changed directions and became something else, right? Like you can see a lot of large startups, lot of large companies today started as something completely different. And they were able to adapt, iterate and change directions and build. Few more examples here. Some of them could be surprising for you today to think Instagram was something else earlier in its life cycle is something you don't think, right? So how do we get customer feedback? Obviously, you need to put something in their hand, they use it, and they tell you, okay, this is good, this is bad, you got it entirely wrong, or I love this part of your application, everything they say, right? So you need to put something in the customer's hand. So you need to ship really, really fast, take that feedback, iterate, give it to them, again listen to the feedback, and it's a process which you need to create as a startup to continuously listen to customer feedback and make it part of your whole life cycle. And also you need to, when you listen to feedback, there are a lot of feedbacks which may not be relevant also, right? Not every feedback is the right feedback. So you need to also have a process to discard what is not working. Maybe you built a new feature, nobody is using it. A lot of people said, I will use it, but they are not using it. So you need to be ready to discard. I like this quote from Henry Ford, who said, if I asked people what they wanted, they would have said faster horses, right? At that point, people could not think there can be something like a car, right? So feedback, again, take it with a pinch of salt and use what is really useful for you and discard the ones which is not working. Cost of iteration, right? So now we are taking the feedback, we are experimenting with our product, we are building out features, we are changing the flows, we are doing all of that, right? What is the cost of iteration as a startup? One is obviously human resource cost. As a startup, you have very limited set of people with you, and say you are building these features, those features are taking a lot of time and effort from your team to build. Next is time, like one of the audience member mentioned. You are also going to lose time. If you are barking off the wrong tree, you are building the wrong set of features and spend like 6 months and then realize, oh, this is not something people wanted, so you lost good 6 months. In the startup world, 6 months is a long time, right? Somebody else could do faster and get it right and beat you to it. So it's very hard there. And the next is infrastructure cost. As you build new and new features, it is not going to be cheap, right? It is going to take some money to run. Somebody says, oh, do this Gen AI thing. Now everybody is saying Gen AI, let's do some Gen AI. And next thing you know, you put OpenAI APIs, you call them and all that. And next thing you know is your bill is so high. And you are like, oh damn, if it is going to cost me so much to run this, it may not even make business sense for me to run this. So there is always infrastructure cost to all the features you develop. And then we have accumulated technical debt. So this is something I go back to my first startup, where marketing team used to come and say, hey, build this promo engine. If you have this, I can do a lot more sales, I can do a lot more marketing, I can bring 10x more people to the website if we had that, this and everything. And you are like relentlessly building so many things. And there is this stat, I don't know where I read this, which says in a fast growth startup, 80 to 90% of the features they build will never get used, right? So there is a massive amount of technical debt which you are accumulating as you iterate. You are building new features. The problem with building new features is you forget when to discard it, because you are always building next new feature. So you lose the track of the things which you have built, which are not being used by the people, and that amounts to a lot of technical debt. So when we look at iterations, what is the cheapest way of doing iterations is by doing mocks, right? Because you are not involving the engineering team, you are not involving cloud, code and all that. You are just creating the workflows. If you have a problem with the image generated here, blame the Gen AI, because I generated using DALL-E. So, so you can use Figma or a similar tool to create mocks and have end-to-end workflows, iterate over that, right? If you have a problem and show it to your customers, because you can create clickable prototypes, show it to your customers, see what they see, empathize with them, and take that feedback into your product and iterate. This is the cheapest way of iteration, as there is no code, nothing, right? Obviously, because it is cheapest doesn't mean it is the best. You have some of the pros and some of the cons. The cons being, it is unusable by the customer. Sometimes visually you say, this is so nice. Like when I first installed CRED, it was like so nice, but later I realized, how do I do this? How do I do that, right? So UI was great, but UX was terrible. So And UX, you only get to know it is good or bad once you use it. Visually, when you see things, it may look great, but when you use, it may not be as good as you thought it would be. So that is one limitation when you do prototyping using something like Figma, right? And it will limit the feedback you are getting from the customers. Another way as a next level would be using something like a no-code, low-code platform, where you actually build a usable product and put it in the customer's hand, and you can get the feedback from the customer, right? So it is relatively much faster to build stuff on no-code, low-code platform, because you have pre-built modules, everything available to you. You don't need to do everything from scratch, so you can quickly do things. I know a few friends in my circle who have built very, very successful startups out of low-code platforms, right? Very smart guys. I can never do that probably because my engineering mind always kicks in and say, oh, I don't like the way it is done. So where do we, let's look at the pros and cons. Obviously, low iteration cost, usable product, unlike Figma mocks, which was like clickable prototypes. But the cons being inflexible, like you want your product experience to be a certain way, and you may not be able to build that on a low-code platform because it has its own limitations, because it has made certain choices and decisions on behalf of you, and you will not be able to change those. Even though it is no-code, low-code platform, there is still a learning curve. Personally, I'm never able to learn and do something on low-code, low-code platform. I kind of always find it hard. I don't know, just personal. Probably some of you might find it more easier to use it. And third one being, this is the worst place to be in, right? Say you had an idea, you used no-code, low-code platform, built a prototype, and everybody is loving it. And now you are hitting the limitation of this platform very, very quickly. That's a very bad place to be in. And it could be limiting because you are not able to onboard more customers, or you could hit the limitations of these platforms really, really quickly while your customers are waiting for you to build the new one, right? So it has its own pros and cons. So when you look at iteration, one side we have no-code, low-code platforms, which is fairly simple to get going. On the other side, we have full set of team building on microservices, containers, this, that, and everything, very complex stuff. So how do we kind of find the middle ground? You don't want to, again, start building everything from scratch, put too much of your mind space into technology as a startup founder or a startup team. You want to focus more on customers, right? So let's talk serverless. So some of the advantages of serverless, it enforces a lot of best practices from day zero, right? Because say you are building a monolith, you're running on EC2, like how I did in my first startup, StyleTag. We kept building new features, and it is running on EC2, and it becomes a huge monolith over a period of time. In serverless, since you have Lambda functions, you are inherently from day zero dividing your applications into smaller chunks, smaller pieces, and composing your applications like that. So it enforces this kind of best practice from day zero because of the way serverless works, right? You will be able to ship and iterate faster because you are again not focused on underlying infrastructure management like in a typical containers or a EC2 ELB stack. You are focused too much on those aspects than to what you are shipping to your customers. Embrace experimentation. Unused features don't incur cost. Thanks to serverless, say you build a lot of new features and people are not using it, you are not incurring any cost because it is pay per use. So you can freely experiment, ship new features, and see if they work. If they work, great, you are okay to pay for it. If they don't work, it is sitting, it is not incurring any cost. Unlike other ways of building applications where you ship all these features, they will sit and eat your resources, right? Maybe there is another feature which is working really great, but all these dead features are eating your resources. In serverless, that won't happen. Experiment without incurring technical debt, again, because we have composed our architecture in a way, it's all smaller pieces. If something is not working, it's very easy to just get rid of that part of your application. You built a new feature using a new service and whatnot, you can get rid of that. Or you can just sit with it, it's okay because it is not incurring any cost or it is not interfering with rest of your application. Another great feature of serverless is you can actually find how much a feature is costing you, right? From the infrastructure point of view, like observability and monitoring tools like Lumigo actually has per function level cost structure also, right? Like based on your user interaction and everything, you can see, okay, this function is costing me this many cents. That is built in, so you can just get going really fast. Uh, they also have fully managed CI/CD both for the backend and the front end. It kind of works like a monorepo where your front end and backend is in the same repository and they are interconnected through an AWS Amplify config file. So whenever you send a PR and send a PR, it automatically triggers the CI/CD pipeline and generates actual URL you can hit and see what that PR has, right? Similar to Netlify or Vercel if you are from the front end world. So you can actually explore what is deployed as part of that particular PR, right? That is all inbuilt and it works with all these different frameworks. Personally, I have used React and JavaScript. I can't vouch for other frameworks here, but I have explored a little bit of Android and iOS when I was doing React Native. But yeah, it generally has a very good integration support, library support, everything. Up next, we have AWS App Composer. If you are a visual person, you can use this, where you get a visual canvas and a drag and drop AWS components, and you can just drag and drop, connect them, and compose your application in a more visual manner. The best part about this is it is infrastructure as code. It is not just visual. You just do it and discard it or anything like that. Behind the scenes, it is generating CloudFormation templates. So you are very like best practices from day zero, right? It has IDE support. It has a VS Code extension. So this interface you can get inside VS Code as well. You don't need to go to AWS console. And this is something I have not explored personally, but it has GenAI code suggestions if you are using IDE extension. So that is also as part of that. Again, this allows you to quickly build something, but this is not my favorite way of doing it personally, because I am more of a terminal and the console guy, right? So my favorite way is up next. Any guesses? Let's see how many people remember from the SAM, right? Okay, people are giving some attention. So AWS SAM, this is again from AWS. It's an open source tooling. SAM stands for Serverless Application Model. SAM is an abstraction on top of CloudFormation. So how many of you have used CloudFormation? Okay. So if you know CloudFormation, it's very verbose. You need to write a lot of YAML to get something moving. So what SAM does is an abstraction on top of it, mostly more on the components which are serverless, like Lambda, DynamoDB, API Gateway, and all of those. So SAM has far less number of code to get the same done from the infrastructure definition point of view. And SAM also has interconnectivity, like you have cognitive authentication. Now you build an API and you want to authorize this with that. So it's very easy to define these connections inside SAM. The best part about a lot of people, when they come to serverless, to explore serverless, they say, okay, I'm writing the Lambda function. How do I test it? How do I check my code? Because you are used to writing locally, and you just keep running or do a watch. You ping the function, you see the logs, everything right there. In serverless, it's a bit more hard because you have Lambda function, you have API gateway, you have DynamoDB, you have all these different AWS services you are using, which is very hard to emulate locally, right? If you emulate all of that, it becomes really hard for you. There is something called as local stack where you can try and do that. But otherwise what happens is you are deploying a Lambda function, using Postman to ping it, and then it says, oh, you missed some syntax. And you're like, damn, I need to spend another 10 minutes to get this going, right? But with SAM, all of that is gone, because SAM has something called as SAM sync and SAM logs. So what SAM sync does, like in a typical environment, you would push your PR, it goes to CloudFormation, it will do difference checks of the infrastructure, and it will do the deployment. Then you can use your Lambda function, right? But in SAM, what happens is it uses AWS SDK APIs to update the Lambda function directly instead of going through all these hoops. So you can run this command called SAM sync and --watch with a flag. And anytime you update, do any changes to your code, it automatically syncs that particular Lambda function code to the function in the cloud. Again, this is not prod. It creates a dev environment in the cloud so that you will be able to simulate the overall serverless architecture more efficiently. And with that, we also have something called as SAM logs. So you can SAM log, again, pass a flag for tailing. And so you do some changes, it says function updated, then use your Postman and ping the URL, you see the logs right there. No need to go to AWS console, nothing. So your developer productivity is really great. You can do iterations very, very fast, and it simulates the local development environment. So that's my favorite tool because of this reason. So because I love SAM so much, we built something called as Rover. It's also sponsored by AWS. It's an open source project where what we did with SAM has inbuilt templates, but it's mostly hello world and those kind of templates. So with Rover, what we have done is we have built little more functionality into generating SAM templates. So very quickly you can easily generate CRUD APIs, you can generate authentication and everything beyond Cognito, right? Cognito has certain ways of doing authentication. Here we have, for example, email and OTP authentication. All of that is inbuilt. You can just use the Rover command and generate a SAM project. Again, this is open source and it generates SAM, so you are not tied to Rover in any means, right? Then we have Hover, probably not a great tool for this audience because it's mostly for front end, but it is cross-platform. It is generally when you see a UI component library, it is mostly only for React, some are only for Angular and all, but Hover is cross-platform. You can use it either Angular, Vue, React, anything. How many of you use SAM here, AWS SAM by any chance? Oh, there are a few people, okay. So if you use SAM, you know that very quickly the template YAML grows to become a very large file. So we have built something called as Shelby SAM, so where you can take out some of the pieces into its own file. Like for example, maybe the database you want to put it in its own file. Maybe the APIs you want to put them in their individual files so that it becomes more easier to maintain the project. And also as a startup, to discard a feature at a later stage, you can just take out the reference and you are done. How many of you use step functions? Okay. Okay. If you use step functions, the normal step functions has a visual chart which comes, flow diagram, right? You can actually see, okay, the request started here, it came here, this happened, that happened, but it is not there for express step functions. So we built that for express step functions. It is called SEG. You can check out. So serverless is the right balance, right? So between going to no code, low code and over engineering, you can come to this middle ground called serverless, where you are not at all focusing on operational burdens of building a application, and also you can use these tools which are accelerators. You have like in Rover you have CRUD, everything, you can generate really, really quickly and get going, right? Majority of the applications, like 70–80% of the code is CRUD most of the times. You have about 15 to 20% where you need to write custom logic, right? So with that, that's about it. Thank you very much.